Okay, Rachel, we're going to talk about section 9.2 of your book. This is the Algebra 2 textbook, okay, section 9.2. And in that section, they deal with graphs and equations of parabolas. Let me remind you of a few things before we go a little deeper into what the section is trying to teach you. You remember what a quadratic equation is, a quadratic function. Basically, in general, the general expression for a quadratic, it has one term raised to the second power, it has one term raised to the first power, and it has a constant, which is really like having x to the power of 0. So you have second power, first power, 0 power. So that's the general quadratic. Y equals ax squared plus bx plus c. Any parabola, any quadratic equation, no matter what the values of a, b, or c, the graph will be a parabola. That's one thing to keep in mind right now. That's the property of a quadratic equation. What is a parabola? It could be like that, passing through the origin. This is the origin, 0, 0, and facing up. What else could it be? A parabola. It could be going through the origin, facing down. It could be going through the origin, facing to the left. So it's going through the origin, facing to the left. It could be going through the origin, still going through the origin, facing to the right. Okay, so all these four parabolas pass through the origin, but they're facing, this is facing the right, this is facing the left, this is facing up, and this is facing down. The only difference in all of them are the values that A, B, and C will take on, okay? Now, you could actually have those that don't even pass through the origin at all. There's nothing that says they must pass through the origin. This will be a perfectly good parabola. This is the origin over here, this is the x-axis, this is the y-axis. It doesn't touch the origin, okay? That's a perfectly good parabola. What about this one? It's facing down. It doesn't go anywhere near the origin. Okay? That's a perfectly good parabola. Okay? So they could be anywhere in the space. The requirements, the typical properties of a parabola is that they are always symmetrical. And it will have the point at which it changes direction and start going back up or back down is called the vertex. So a parabola is symmetrical, meaning that it has a line of symmetry. So this one, for example, in this, let's look at this green one. Okay, well, let's look at this one because it's not so crowded over here. This one. Okay. So its line of symmetry will be like that, right? Coming through the vertex. That is, it will be the mirror image of what is on this side will be on that side, okay? So all parabolas are symmetrical no matter where they are on the space, they're symmetrical. That point through which the line of symmetry crosses the parabola itself is referred to as the vertex. What is the plural, by the way? What's the plural of vertex? Vertices. Just so that you know that. That's the plural of the word vertex. It's called vertices. Okay? Okay, so let's leave this side here for now. Now, note, however, that the requirement for a parabola, for a quadratic, only A must be non-zero. That is, If a is 0, as you can see, then this term goes away, and now you are y equals bx plus c. Well, you should recognize that as a straight line if there's no x squared, right? So the only requirement really is that a cannot be 0 for you to have a quadratic. It's okay for some quadratic, b could be 0, so there's no x term. For some other ones, c could be 0, so there's no constant term. Or both b and c could be 0. So the only term you have is this term that has the second order. So it will just be y equals ax squared. So you can have all those. So only a cannot be 0. All the other terms can be 0, okay? B could be 0, C could be 0. Now, the special case when B and C are both non-zero, are both 0, when B and C are both 0, B is 0, C is 0, that special case, of course, you can recognize it is y equals ax squared. In this special case, we call it a special case because the general case is that, but a special case is when we said, okay, B is 0, C is 0, okay? In that special case, then the parabola will always pass through the origin. Okay, you must remember that. That's one fact that we have now established. When there's no bx, there's no x term, this one, and there's no c term, that one, it's just the quadratic term, the second order term. Okay, if that's the only one, then the parabola will always pass through the origin. Okay, all right. I hope you got that. I'm going to clean this up and we're going to do more now.